Great, we are having an introduction to graph traversal algorithms by way of using water pitchers problem. In the water pitchers problem, we're given pitchers of sizes A and B, and we want to make C units of water. For example, we could have been given two water pitchers of sizes 5 and 8 units of water, and we want to arrive to a situation where one of the pitchers has 1 unit of water. So we cannot take half of 8, such as 8 becomes 4 and 4 becomes 2, etc. All we can do is we can just move the water around between the two pitchers. Okay. So as a generalized step, what we can do is we can empty one of the two pitchers, either of the two pitchers. We could fill one of the two pitchers. We do have an infinite supply of water. We could move the water around. Now we have to be careful in the sense that if we move the water from the first to the second could either fill up and still have some water left, or the second doesn't fill up and we are able to empty the entire first pitcher into the second. Those are the two different cases that we see here when moving the water from the first to the second, second to the first, etc. Okay. So the main idea is that we will generate a graph with vertices and edges dynamically as we make these moves, and each move will give us a new or already seen vertex before. The vertex in this case represents the state, essentially saying that the first vertex has X units of water, the second vertex has Y units of water, the second pitcher has Y units of water. So we will conduct a depth first search on this graph to search for the solution. The solution in this case is the path. The path conveys the step-by-step solution here. So overall possible solution is that we'll be in a while loop. We'll keep making a transition step. If we find what we're looking for, great. If not, we're still in the loop. However, the problem that we have to avoid is that we could go into an infinite loop and not find new states. So we could start with 0, 0. We fill up the first one, we get 5, 0. We fill up the second one, 5, 8. We empty the first one, we get 0, 8. We empty the second one, we get 0, 0. And we're back to where we started from. And if we're not careful, we'll keep going through that loop and never hit our solution, which is shown here on the left-hand side, in which we do get 1 unit of water in the second pitcher. That's the reason we study graph traversal algorithms. So graph traversal algorithm is an algorithm to traverse the graph in a systematic way without going through the same vertex again and again. There are two main graph traversal techniques. There are many others that are combinations slightly different from these, but these two main ones are depth first search and breadth first search. Both have their pros and cons. We will cover both. Watch out for those videos. And the overall graph traversal algorithm falls within the design portion of the analysis and design of algorithms. There you have it.